Hello, everybody. A very warm welcome to a new season of Rethinking Resources. I'm your host, Steve Shade, and we are talking about an entirely hot new topic this time. In this episode, we will be drilling down on what appears to be an obvious energy transition solution that has, for reasons we will be investigating in the coming minutes and in the coming episodes, so far failed or fallen a bit short of gaining real traction. We are talking about geothermal energy, an infinite source of clean, safe, and renewable energy right beneath our feet. To find out all about how it works, why it isn't being used widely today, and whether it will be widely used tomorrow, we have a very special guest with us in the studio, Edith Haslinger. She is a senior scientist for sustainable thermal energy systems at AIT, the Austrian Institute of Technology. AIT is Austria's biggest research and technology organization. AIT thinks very big on energy solutions like geothermal and has positioned itself to work with industry to transition to pursue these bold solutions. Edith Haslinger, a very warm welcome to Rethinking Resources.
Thanks for having me.
To get us started in this episode, please try to give our audience a concise definition of geothermal energy and explain everything that it promises.
Yeah, with pleasure. So geothermal energy, very concisely, is the heat that is generated within the interior of the planet Earth, so right beneath our feet, as you rightly said. It comes from natural processes within the interior of the planet, and then this heat is transferred by convection to the surface of the Earth, and this is the heat that we can use. So this is already the first big advantage of geothermal energy. It is an energy that is it's generated within the earth by itself, by processes. So it's abundant and it's renewable and it's there all the time. It's independent of seasons, of pricing. So it's there. So it's there for free. And our task is to develop technologies or to use technologies to extract that heat from the earth that is there in the first place.
So you just listed many merits. Why aren't we all tapped into it already?
Yeah, so geothermal energy, it sounds so easy, but of course, when you want to extract the heat and use the heat for space heating or for industrial processes, then you have to drill down to some extent. Normally, this goes with drillings, shallow drillings, deep drillings. So you have to drill, and the heat is not distributed around the globe like evenly. Obviously, in areas where you have, for instance, volcanic activities, the so-called heat flux to the surface is very high. And then, for instance, in countries like Iceland or Indonesia or Japan, or also in the west of the United States, where you have also active volcanism or active earthquakes, there the heat flux to the Earth surface is very high. And the heat is not evenly distributed around the globe, and this is one of the big challenges. And then you also have to have the techniques like drilling rigs. So you have to in some areas where you don't have so much heat flux, like in continental Europe. You have to drill down to several thousand meters for really high temperatures. So, and this is not an easy task. So there are some technological challenges, also geological challenges, and you have to have a long planning phase when you really want to extract like the deep geothermal potential. The other thing is the so-called shallow geothermal, which most people know as borehole heat exchangers or groundwater heat pumps. It's much easier. So for space heating, for instance, so it's not such a geological or technical challenge. So for space heating, it's also good to use this shallow geothermal and to use the really deep drillings when you need them, like for industry or for district heating.
Okay, we'll dig deeper into the technological aspects in a moment, but I think it's important to address a conspiracy theory, a worry that is important to clarify. That involves fears that there may be a danger associated with letting the heat out of the core of the planet. Is it dangerous that we let too much heat out too soon?
Yeah, this is a common misconception that many people have, and this is rooting in a misunderstanding of the scale of from which we extract the geothermal energy. So, just speaking shortly about the planet, we drill normally when we say about deep geothermal drillings, we drill in Austria, for instance, for 5 to 6 kilometers at maximum depth, and then this is just like the upper layer of the Earth's crust, which is the outermost layer of the planet. The crust is between 40 and 70 kilometers thick, and then comes 6,500 kilometers of till the Earth's core. So when we drill, even the deepest drillings just scratch on the surface of the planet. So the heat content of the whole planet, in the whole volume, is much more, several trillion times more than we could ever use in heat. So it's really the scale that we use geothermal energy is really minuscule compared to the whole volume of the planet and the whole heat content. We can never cool down with our activity, even if everybody uses geothermal energy from now on.
Okay. Thank you for clarifying that. So then let's talk about where it is being used successfully and widely. You mentioned Iceland, where geothermal energy literally bubbles up to the surface. The usage there is close to 70%, which is astounding. But why not elsewhere? Globally, current use is minuscule. Why?
It's like when we take the example of Iceland, like you said, the heat is bubbling up on the surface. So all the countries that have this active volcanism where the heat flux is very high. So we have Iceland in Europe, also Italy, the west of Turkey, but also maybe you know the ring of fire around the whole Pacific, so west of USA and Japan and so on. There the heat flux is very high, and you can use geothermal energy much more easily than when you not have high heat fluxes. So it's bound to geology, so those countries with the highest heat fluxes to the surface, they are the leaders in geothermal energy use. For instance, the highest installed capacity for electricity generation from geothermal energy is the United States, which may become a surprise for many people. So they are the global leaders of geothermal energy use for electricity generation, and then followed by countries like Japan, Indonesia, Philippines, New Zealand. They are the followers. And when we just speak about the heat use, the direct heat use, so extracting heat for heating purposes, direct heating, China is the absolute global leader by far, and then followed by Turkey for direct heat use from the deep geothermal underground. So this is one of the points, that you have to have the suitable geology. So this is something you have to take into account. And then the other thing is that up to now, the whole energy infrastructure was bound to mostly fossil fuels. So first coal, and then oil, and then now gas. And so our whole infrastructure has been built around this the distribution of burning fossil fuels and transporting this heat to the houses or to industries. And now we have to rethink that. So now everything is changing. So everybody's going in the direction of renewable energy. And so the distribution of renewable energy is sometimes completely different than from burning fossil fuels in like incinerators or in plants, and then distributing. So we have much more now this decentralized approach, where you have your community or your dwelling or your industrial plant, and then you really have to look how to distribute your renewable energies that you have, not only heat for heating from geothermal, also from solar panels or wind farms. And so it is completely changing. The whole energy world is completely changing, and geothermal is one of the renewable energies with it.
Okay, but staying on this note of the technology, the cost, and why it hasn't been pursued more aggressively in places where it's more difficult to get to, is it a situation where the deeper you go, the higher the cost?
Yes, absolutely. Drilling 4 to 5 kilometers deep into the crust is not an easy task. And the deeper you go, the deeper you drill, the higher the costs, because you need. This is also a material issue. You have to see when you have a big drilling rigs for deep geothermal drilling. It's not easy to drill 4 to 5 kilometers into the underground. It's also a matter of that you have a long planning phase before that, because the geology, local geologies are very different in different areas. So geology varies, and it's not like you have the underground layers like flatly lying one beneath the other. So the geology is bound to tectonic processes, and sometimes it's really folded and upside down, and you have to know that before you drill inside. You have to know your structural layout of the underground before you can drill. And obviously you can't look into the underground like you don't see what is inside. So you have to know from geological models or also seismic imaging, what are the layers and where are your water-bearing bodies, where you have the hot thermal water to extract. So the planning phase is one part, and then is the drilling phase. And the drilling costs are really, the deeper you go, the higher they get. And especially everything below 1,000 meter below surface is normally getting harder and more costly. That's the point. And so we really have to look at where do we need deep geothermal for high temperature process heat or district heating, and where maybe we shallow geothermal, which goes normally down to 300 meter below surface, or medium depth geothermal down to 1,000 meters is sufficient. For instance, for space heating, we don't always need necessarily deep geothermal.
And is it then used locally? Is it difficult to take that energy, that heat, and transport it great distances?
No, it's not necessarily difficult to transport, because more or less it's hot water that you transport. But normally, to avoid like transportation costs, then you drill in the vicinity of your usage. When you have to transport it over, say, some kilometers, you use highly insulated pipes, the same that you use for district heating, to transport heat from district heating. So normally you avoid that. And even when you come to lower temperature, like from shallow or medium depth geothermal, it's even easier, because then you just use normal water pipes to transport that. But normally you see to it that you drill close to the usage, and that's also one advantage.
Okay, let's address some other challenges. The very tricky thing about drilling down into heat sources is that they get really, really hot. Even in Iceland, they've drilled down into tremendous heat, tapping into magma, corrosive gases that destroyed or melted some of their equipment. So it seems to involve a bit of guesswork, learning from experiences, and the consequences of failure are quite expensive. Is that right?
Yeah, this is right, but it's not related to guesswork. This is something that you have to you deal with in the planning phase already, and this is something I deal with that a lot, and it's very exciting to work on that. Because I'm a geochemist, and this is exactly my field that I'm dealing with in deep geothermal. So when you drill down, you have a number of challenges. You take out water that is normally highly mineralized, because the water is in contact with the underground rock, obviously. So it takes up all the minerals, so the like calcium and so on, elements like that. And also you have sometimes you have salt and you have gases, and when you extract that and bring it to the surface, it interacts with all the piping that you have underground, and also with the above ground things, components like heat exchangers, pipes, and everything. And you absolutely have to know in advance before you drill what the water composition will be like. So this is something we look at in the pre-planning phase, so very early. It's good to know that, and then you can choose the equipment accordingly. So this is something everybody involved in deep geothermal exploration is aware of, this hydrochemistry, that you have to take this into consideration, pay a lot of attention to that, and then you can plan your underground and also the above ground components accordingly.
So fantastic. Smart people doing smart things. You mentioned some very good examples of countries that are pursuing geothermal in a big way. But let's bring it back to Europe. In this part of the world, who's really going for it?
Now we have, of course, let's start in Austria, because also this is the OMV podcast. So now the city of Vienna and the energy provider Wien Energie and OMV have joined forces to really develop the Vienna basin to provide deep geothermal energy for the district heating. So Vienna is now one of the big players in Europe, really, you can say, with that, if this comes into realization. And then in Europe, we also have a lot going on in Germany and in France and also Switzerland. So these are the big players. In Italy, where we have the oldest geothermal power plant, there is still huge potential.
You have to name it. Where is it?
Ladarello. It is. I could visit it last year for the first time. It was really exciting. And also in Turkey, we have a lot of geothermal plants, mostly for power generation, but also for heat extraction. And so this is in Europe. But there's all over the planet and also in Europe, especially, and also in everywhere, there's the installed capacity is really a tiny fraction of what the potential would be. So what we do now, what we have been doing the last 10, 15 years is really promoting geothermal energy everywhere to bring the attention to this technology, which is really like old technology, is nothing new. So the first heat pumps or the first drillings for thermal water, they have been known for a very long time. The Romans knew that there are hot sources, water sources, and all the bathing culture. So it started very early, and now we're working very hard to bring people to communicate also the advantages that there are obviously for geothermal energy, and now people start to acknowledge the technology and also the easiness and all the advantages. And so now we have a lot to do, which is very fortunate. And now people start to see this, and also as one of the parts, one of the renewable energies. And also what was very challenging was in the last years is that nearly nobody spoke about heat. Everybody, when you followed the media about renewable energy, everybody was talking about electricity or transport, which are very important topics, but nobody spoke about heat, how important that is. And now, since 2 years, and we know how dependent we were on external fossil fuels and especially gas, and that maybe this is not such a good idea, and that we can also quite easily use our local resources for heat and also for electricity. And it's a very important part of this heat transition and energy transition.
So you mentioned how much you have to do. Let's talk about the challenges at the Austrian Institute of Technology, and more about, did the challenges come to you, or are you chasing the challenges? How did that all evolve?
I would say until 2-3 years ago, we were quietly doing research in geothermal as geologists. We pursued projects where we could bring in geothermal research in geothermal heat pumps and everything connected. Now, since 2 or 3 years, the projects and the inquiries are chasing me and our group, and so we really have a lot to do. Which is, but it's really nice because people really, you see the shift in the perception of energy. Nobody, like when you talk to your friends or your family, nearly nobody, energy was never a real topic. Nobody thought about where the energy for your lighting or for your heat for the radiators is coming from. Now this is like an everyday topic even at the Christmas table. And this really changed in the last 2-3 years. And now people start thinking, and now with the energy prices, everybody thought, okay, now my prices are so much higher. Why is that? And this helps a lot. So people change their perception of energy and how it is used. And this is very important for us.
I think it's worth noting that drilling for oil, drilling for gas was also super cost intensive. Geothermal, as we have discussed, is also cost intensive. Is it more or less expensive? Is it a matter of taking the old technology and applying it to new challenges?
The comparison between the two is I don't know if that's really the point. I mean, if you drill for oil and gas, you use drilling rigs, and so for deep geothermal, when you want to extract deep geothermal, so it's the drilling technology is similar. And now this is our great hope, and we are really happy that OMV is now pursuing also geothermal energy, because the knowledge of drilling and the knowledge of extracting fluids from the underground, from deep underground, this is a know-how that we absolutely need in geothermal. And now it's more or less the same procedure, only that in oil and gas exploration, the hot water that comes up with every drop of oil, this was the unwanted product. Now we are pursuing the hot water, so the technology is the same, and also the distribution system is comparable. I think it's now a matter of seeing that geothermal energy, the hot water, without any CO2 emissions, and this is the crucial point. Now, when you burn fossil fuels like oil and gas, you produce a lot of CO2. Everybody knows that, and this is something we want to avoid. So it's not a matter of cost, but it's a matter of the cost for the now and future generations. And this is something you have to take into consideration. So it's either you want a technology that is that fossil fuels you burn, you produce a lot of CO2, driving climate change, or you transition to renewable energies. And this is not a matter of cost, in my opinion. This is a very it's a society challenge, and this is now we have to do that. We can't go on like that. We used before.
Is the drilling down really safe and really clean? It seems like many people have concerns that it's similar to fracking, that it uses dangerous chemicals during the drilling process. Is geothermal drilling different?
It's fundamentally different, really. It's fracking is that you hydraulically fracture underground layers, rocks, in order to pursue small droplets of oil and gas. So it's the extraction of fossil fuels, and this is a very energy intensive process to really fracture these very tight underground, or like this tight rock layers, and then you extract fossil fuels. And for that you need a lot of water, and you need chemicals, and you need sand and everything. Drilling for geothermal, for hot water, is something you drill a hole and then you pump up hot water. So it's like a very big water pump, and with higher temperatures. So it's fundamentally different. Geothermal drilling has absolutely nothing to do with fracking, because it's completely different goals and a completely different technique.
And then another question on worries about drilling down and making things unstable. Is it true? Is it dangerous that geothermal drilling can set off earthquakes, cause instability in the ground below us? Are these concerns real? Are they being taken seriously?
Yeah, they're absolutely being taken seriously in the geothermal community or the geothermal industry. So it is absolutely acknowledged and taken into considerations. There have been 2-3 examples where earthquake induced seismicity, so triggered by human activity, set off mini earthquakes. But those earthquakes have been many magnitudes lower than the normal, like natural earthquakes from tectonic processes. But this has to be taken absolutely seriously, because it's also some of the things that we are asked a lot about. Is it safe? Does it cause earthquakes? So when you plan deep geothermal project, even in the planning phase, there is a planning just for monitoring seismic activities during drilling and also during the extraction of the fluids. So normally around a deep geothermal project, there is a huge network of seismic monitoring during the drilling phase and also during operation. So this is absolutely taken into consideration, taken seriously. And there has been a lot of research going on about induced seismicity in connection with deep geothermal. So the very few examples where there were like mini induced seismicity around geothermal projects, this was really taken seriously in the community.
Everywhere? Is there a danger that some places are going to go for a geothermal without having high-tech seismic equipment and sensors?
I cannot speak, of course, for everybody or each country, but I know in Austria this is everything that is going on now in Austria. The deep geothermal projects all have a close network of monitoring for induced seismicity. But just to reiterate, the induced seismicity from deep geothermal projects up to now was many magnitudes smaller than normal earthquakes. So, but of course, you have to know that in advance. You also have to know your underground layers. So this is one. So if you have some layers that react to drilling, like gypsum layers that swell and cause tectonic movements, small tectonic movements, you have to know that. But you have to know your underground in any case. Not only for induced seismicity, you have to know also for your drilling equipment. You have to choose your drilling equipment accordingly. So when you look at the underground layers, if you have a solid bedrock or you have a loose like sediment, you also have to know that in shallow geothermal drilling. So you have to know what your underground is composed of, and then you have to know if there is something that could trigger this induced seismicity, as it's called, and or if there's something else that you have to take into consideration.
So the interest, the optimism, the enthusiasm has long been there. The International Energy Agency several years ago mapped out a super optimistic growth scenario. Nonetheless, interest in the technology remained lukewarm, hasn't lived up to these super optimistic projections. What has held it back?
Yeah, it's we've talked already about the perception of geothermal energy, that it's costly, it's complicated. You have to drill several kilometers, and everything is so expensive. But now the perception really changed for that during the last 2 or 3 years, because now deep geothermal, for instance, is used for district heating networks or single industries. But now, and people were a little bit reluctant to invest into geothermal energy. Of course, the drilling costs, which are about 50 to 80% of a deep geothermal project, if one single user, like one industry or small community, has to cover the drilling costs, then of course it's something that because everybody looks at investment costs beforehand, and if you have a deep drilling, it amounts to several million euros. So you have to find somebody who is willing to invest into the drilling itself, and also the long planning phase before that, because it has to be planned very thoroughly, such a deep geothermal project. And now this changed now from single user drillings to when you look at deep geothermal not as a single user solution, but more as an infrastructure project for a bigger use, like in a whole community, in a whole town, for like an industrial park, then it makes much more sense. And this is something that is changing very much now, that people say, okay, I would be interested into deep geothermal because I have like an industry with 150 degrees centigrade process temperature. Maybe I go to the community that I'm connected to and say, let's drill together and let's all invest together in one deep drilling, and I have my process heat and you can have it for your district heating or for your local heating and cooling network. This is now changing, and there has been really, since the last 2-3 years, there have been several trigger points where people really think about like these joint solutions, the joint development of geothermal, and also not to see how we only have a deep geothermal for a high process temperature, for high temperature for district heating. We also can use a shallow geothermal or in connection. So we have deep geothermal for the processes where we need it. And then we have shallow geothermal, for instance, for heating and cooling for space heating. So you don't necessarily need the high temperatures from deep geothermal, for like space heating, when you have like a very efficient passive house where you just need 30 degrees centigrade. So, and this is something, so everything is more connected. Also, the perception of energy use is more connected. And so now I'm very positive that the whole thinking about energy as it is now changing. We see that, and also we talk a lot with communities, with industry, and see, okay, it's not only you're important or your case, but maybe look around your neighborhood. Maybe somebody can use your residual heat from when you are after industry. You can use it for space heating.
So looking out across the world and beyond beyond Austria with your expert eyes, do you see this as a momentum story? Do you expect some positive tipping point to push us over the edge firmly in favor of geothermal energy and massively expanding its usage?
Yeah, I certainly hope so. There have been some tipping points, and one of the most important was that geothermal energy is now really in the heads of people, but also in the heads of decision makers and also policy makers, like ministries and funding agencies. This has taken a while, but now geothermal energy is really spoken a lot about in Austria and everywhere in Europe. And now this has taken us the last 10 to 15 years to really continue speaking about geothermal and the advantages of geothermal. And now people really think differently. We see that, and also the perception of ministry, and also when big companies like OMV or the Wien energy provider, they really have ambitious goals to invest into geothermal, and they really have ambitious goals also for exploration and for implementation of geothermal. Then this really helps. So it's not a single family house owner that decides for borehole heat exchangers or ground water heat pump. This is really nice, but we really need big projects now on a bigger scale, and this is now in process, I would say. So I'm positive.
Okay, so final question. We'll take us out into the vision phase. We can hear that your heart is in it. And let's put your scientific mind in it as well. What is your expectation from the future? Do you see this ramping up from what you described as ambitious local projects to powering entire cities, and then beyond? Paint us a picture of the future you see.
For me, the future is now. We are in the middle of the heat and energy transition. So everything is happening really now in real time, and we can see like a huge shift in perception, and also that we, for the first time, have really ambitious goals and people investing big time into geothermal and also renewable energies. And so my vision is that geothermal is one of the main pillars of the heat transition, especially for space heating and also cooling. So because you can use the underground not only for heating but also for cooling, and the deep geothermal for industry and district heating. And I'm very positive that we have now very good momentum for really big solutions on a bigger scale. Like I said before, it's not about the single family houses or single users, but now we have to really invest big time into the heat transition. And so I'm very positive that geothermal is an absolute crucial pillar in that.
That's a nice picture of the future. Thank you very much. Edith Haslinger, thank you so much for sharing your thoughts, sharing your ideas, your inspiration and insights with us on Rethinking Resources. To everybody listening and watching, either listening on your favorite podcast platforms or watching us on the OMV's YouTube channel, if you have feedback, if you have questions, please send us a message to podcast@omv.com. We would love to hear from you. For more background information on all the topics we have been discussing in this episode with our guests, check out our show notes where you'll find links to lots of valuable information. Thank you so much for sharing your time with us, and we hope you will join us again for the next episode of Rethinking Resources.